Hello students, in this video we'll discuss binomial random variables. A random variable x, which maps a sample space into the real numbers, is binomial with parameters n and p if its probability mass function has the form. So let's write down the probability mass function. So p of k, which is the probability that x is equal to k, is from n, choose k, p to the power k, and then 1 minus p to the power n minus k, for k equals 0, 1, 2, 3, up to n. And so what does this binomial random variable model? Well, what we can imagine is if we have our experiment has n independent trials, and what this random variable models, then x models the number of successful trials. So an example of this would be the following. Example, we can suppose that x models the number of times a heads comes up on n flips. Then we can say the probability that x is equal to k is from n, choose k, we need to choose n, we need to choose k of the n flips that result in a head, and then we'll have 1/2 probability of getting a head, and then 1/2 probability of not getting a head, or a tail, and this is for a fair coin. And if we modify this, we could say that we also can do this for a bias coin. The probability that x is equal to k is n, choose k, p to the k, where now p is the probability of getting a head, and then 1 minus p is the probability of getting a tail. So that's the typical example of a binomial random variable. And now what we can do is we'd like to compute the mean of a binomial random variable. So how do we compute the mean of this thing? So if I compute the expected value of x, what this is this is going to be the sum, k goes from 0 up to n, of k, and then n choose k, and then we'll have a p to the k, and then a 1 minus p to the n minus k. And so we have to observe this binomial coefficient over here and modify it a little bit. So what will happen over here is that if we look at k times n factorial over n minus k factorial, we see I can write this as n times n minus 1 factorial over n minus k factorial, and then k minus 1 factorial. And we see that this is exactly equal to n times the binomial coefficient n minus 1, choose k minus 1. So filling that expression into this formula, we have the sum, k goes from 0 up to n, of n, and then n minus 1, k minus 1. And I'll pull 1 p out of that p to the k and leave this as p to the k minus 1. And then I'll have a 1 minus p to the n minus k. And so what we have here is I can pull this np out. So I have np, I can factor that np out, factor that n out, and factor that p out. And what's left, as you can check, is exactly going to be equal to what's left over here. So I'll have n times p. And what's left will be p plus 1 minus p to the power n minus 1 by the binomial theorem. And so I'm just going to use the binomial theorem over here. And we say that this quantity in the set of parentheses is equal to 1. So the mean, or the expected value of a binomial random variable with parameters n and p, where n is the number of trials and p is the probability of success, the mean of such a random variable is n times p. Thank you very much.